Hello everyone. Today we are going to discuss about the formation of a standing or stationary waves in a stretched string. That means when a string is stretched between the two rigid supports, if that string is vibrated, then some loops are formed. Means when a two progressive waves are having same amplitude, wavelength and frequency and traveling with same speed but along the same straight line but in opposite directions some new set of waves form. That waves is called as standing or stationary waves. Means when two sets of progressive waves are with the same amplitude, wavelength, frequency, time period and moving with same speed or traveling with same speed but in opposite directions, a new set of waves will be formed. That waves is called as standing or stationary waves. In that case, when here is the one wave is traveling like this in this direction, in the positive x direction, and another reflected wave is also moving in this direction to the opposite to the incident wave. Opposite to the incident wave. Two sets of progressive waves are in moving with same amplitude, same wavelength, same frequency, same time period, and but in a opposite direction. Means one wave is traveling in this direction and another wave is moving in this direction. So that's why here the new set of waves are formed. This waves is called as standing or stationary waves. In this case, the loops are formed between the two rigid supports when the string is vibrating. If the vibrating particles of the string means there is no any energy is transferred from one place to the another place, but the vibrating particles are vibrating from its initial position to the its mean position to the simple, it will be in a simple harmonic motion. So that's why here the when maximum displacement of vibrating particles, if the resultant displacement of vibrating particles is maximum, is known as antinode. Antinode. When the maximum displacement of the vibrating particles is called antinode. If in case of the displacement or the resultant displacement of vibrating particles are zero, that is called nodes. Here once again, when the resultant displacement of the vibrating particles is zero or minimum is node and the resultant displacement of the vibrating particles are maximum is called antinode. Here the nodes and antinodes were already denoted. This one position is a node position and this position is a antinode position. So whenever node, antinode, node, antinode, node, antinode, whenever the consecutive, the distance between the consecutive antinode to node is lambda by 2, that is called as half wavelength. Then if in case of two successive nodes having the same phase or two successive antinodes in the same phase is called a wavelength. The two successive nodes are two successive antinode means here is that this one is the one successive antinode and another one is this is the another successive antinode which is having in same phase but this particle is in opposite in direction, so that's why we can't measure this one. If in case of here is the one node position and another one is here is the another node position because of the vibrating particles are in this direction. But in case of in this place, the vibrating particles are in this direction, so opposite in phase. We are saying that whenever they are in the same phase, then that will be called as a wavelength. Here is when wavelength is equal to the time period. So here the what is node and what is the antinode position, what is the distance, what is the determination of nodes and antinodes position is. We can calculate into the this one. Here is that once again the stationary or standing waves means when two sets of waves of same amplitude, frequency, wavelength and traveling with same speed in along the straight line in opposite directions superimpose a new set of waves formed. That waves is called as standing waves when the maximum displacement of the vibrating particles is called as antinode. That position is called as antinode position. If in case of the displacement is minimum, that position is called as a nodes, means a node position. The minimum displacement means here is the zero displacement or zero amplitude, also we can say it as zero amplitude or zero position. Here is the maximum amplitude or maximum position. Okay. So next, here is the how do we find out the values for nodes or antinode. The determination of node and antinode for the equations are. So the equation for the standing or stationary waves are, we can consider two progressive waves are traveling in a string along a straight line. If in case of the positive x direction, when the wave is traveling along the positive x direction, that is y of with respect to its time and position is a sine of kx minus omega t with when the wave is traveling along the positive x direction, and when the wave is traveling along the negative x direction is y2 of x comma t with respect to displacement of second wave, reflected wave, y2 of x comma t is equal to a sine of kx plus omega t. Kx plus omega t means that is moving in opposite direction. So that's why we are taking the two equations. Already earlier we have discussed about that. How do we take the waves? Whenever the wave is traveling along the positive x direction, we will take it as y is equal to a sine of kx minus omega t. And if in case of negative x direction, the equation will be y is equal to a sine of kx plus omega t. Earlier we have discussed about the equations, where displacement equations earlier. So from that, according to the principle of superposition of waves, according to the principle of superposition of waves, y is equal to y1 plus y2 be the equation for principle of superposition of wave. So in that case, if we substitute these two equations in this y is equal to y1 plus y2 equation, then we can get y is equal to a sine of kx plus kx minus omega t, and the y2 is equal to a sine of kx plus omega t. Two equations are substituted. Then from the mathematical formula, sine of a plus b plus sine of a minus b. From the mathematical formula, sine of a plus b plus sine of a minus b is equal to 2 sine a cos b. From the equation, the amplitude taken as common. So because of 2a sine a means kx, and cos b means omega t. So that's why y is equal to 2a sin kx omega t. This is the equation for standing or stationary waves to formation, to take how much the distance for the nodes and antinodes, where the nodes and antinodes are formed. It depends on its length, and also its amplitude also depends on its displacement, also depends on amplitude also. Then when the normal nodes, condition for the nodes and antinodes, and how do we find out the nodes and antinodes, and how much the distance, what is the distance for nodes and antinodes in the given string. Then the condition for the nodes is the position of zero amplitudes. Zero amplitude means when the wave is traveling in this direction, then this will be the zero amplitude. Means when the wave is traveling in positive x direction or the negative x direction, doesn't mean that the maximum displacement is called as amplitude. It is the maximum displacement of vibrating particles. It's called as antinode. But in case of the amplitude is zero, means the minimum displacement of vibrating particles, there is no any amplitude. Amplitude is equal to zero. This is called as a node. The displacement, where the displacement of vibrating particles is zero, means zero amplitude. Zero amplitude is is known as a node position. Is called a node position. So that's why here it is a dash is equal to 0, means amplitude is equal to 0. From that equation, then we can get sin kx is also 0. Sin kx is also 0. Then generally sin theta is equal to 0, then we can get theta is equal to n pi, because of where n is equal to 0, 1, 2, 3 up to so on. If we substitute the 0, then we can get theta is equal to 0, sin theta is equal to 0, 0, theta is equal to 0. Then we can get 1, 5, sin 180 is equal to 0. Like that, that is equal to 0, 1, 2, 3 up to so on. We can get how much the distance, the first loop, second loop, third loop, whatever it is. Then kx is equal to n pi. kx is equal to n pi, because sin kx is equal to 0, then kx is theta is equal to n pi. Theta here it is the kx and 0 means by the n pi, so kx is equal to n pi. But we know the angular wave number, from angular wave number, that k is equal to 2 pi by lambda from the formula. K is equal to 2 pi by lambda. If we substitute this k is equal to 2 pi by lambda in the equation, then we can get 2 pi by lambda into x is equal to n pi. 2 pi by lambda into x is equal to n pi. If we cancel both sides, then we can get only whenever x is equal to lambda taken to this side, it will become the numerator, and lambda, the 2 is it in the numerator, whenever taken to this side, then it will become the denominator. So x is equal to n lambda by 2. Here is the n is equal to 0, 1, 2, 3 is the positions of nodes. Positions of nodes, the number of nodes. The 0 position means here the position is 0, number of 0. So that's why if you substitute this 0, x is equal to 0. Then x is equal to n is equal to 0 means x is equal to 0. Then here is the another node is there. Here it is n is equal to first node. Then first n is equal to 1. Then the distance will be the lambda by 2. Lambda by 2. Then if in case of the third node, here is the second node. 0 node, first node, second node. Second node means here is also one of the lambda by 2. Means lambda by 2 plus lambda by 2. 2 lambda by 2. This is the nodes are formed. In these positions the nodes are formed. This is the value we will find out that x is equal to n lambda by 2. This is x is the position of nodes. X means by the position of nodes. So we will find out n is equal to x is equal to n is the 0 up to, so n is equal to 0, 1, 2, 3 up to so on is the positions. X is the position, then the number of nodes are formed. N means by the number of nodes formed. From this equation we can get the what is the length? What is the length of the total nodes or and nodes are formed? Then this is about the condition for the nodes. Next we are going to discuss about the condition for antinodes. So the condition for the antinodes are the points of 0 amplitude is called as nodes, and now the points of maximum amplitude means where the amplitude is maximum, means when the wave is traveling in this direction, then the vibrating particles are at high. It means maximum displacement. It's called as amplitude. The maximum amplitude of the points is called as antinodes. To know the condition for the antinode is amplitude is maximum. So that's why A bar is equal to 2A. From the 2A sin kx cos omega t formula, we can get amplitude is 2A. So that's why sin kx is equal to, we can get plus or minus 1, means where the maximum means it is at 90 degrees. So that's why we can set as that 90 degrees means the plus or minus 1. Either positive x direction will get the plus 1. If in case of negative x direction is, we can get the minus 1. From the antinode condition, further when the vibrating particles are maximum, then according to the general solution, the sin theta is equal to plus or minus 1. So that's why we are writing that 2n plus 1 into pi by 2. Pi by 2 means 90 degrees. 90 degrees means here the theta is equal to 2n plus 1 into pi by 2. We can get that the maximum displacement value. So that's why we are taking that the k is equal to kx. Kx, we know that from the angular wave number, k is equal to 2 pi by lambda. K is equal to 2 pi by lambda from the angular wave number. If we substitute this, k is equal to 2 pi by lambda in the above equation, then we can get by cancelling the pi of both sides, then 2 pi lambda into x is equal to 2n plus 1. Then according to the position of vibrating particles along the string in a straight line, then we can get x is equal to 2n plus 1 into lambda by 4. That means here if we where n is equal to 0, 1, 2, 3 up to so on, the positions of antinodes is the value number of antinodes. Here the n is called as the number of antinodes formed of the string, and x is the position of that antinode. So that's why we are taking that 2 of 0 means we can get that lambda by 4. If the first harmonic means first antinode, then n is equal to 1, we can get 3 lambda by 4. And the second antinode means here the distance is lambda by 4. First antinode. If in case of second antinode, the distance at position in second antinode is 3 lambda by 4. Means the distance from the initial position to the second antinode distance is 3 lambda by 4. At a distance of from the origin to the 3 lambda by 4 wavelength, the length, then we can get the second antinode and the third antinode. Here is the third antinode. Then we can get the third antinode is at the pi by 4, 5 lambda by 4, because of if in case of n is equal to 2, 2 to the 4 plus 1, 5 lambda by 4 be the third antinode position. This is the third antinode position. The distance from the origin to the third antinode position is 5 lambda by 4. This is the about the antinode condition. But in these distances, in these positions, at the lambda by 4, 3 lambda by 4, 5 lambda by 4, 7 lambda by 4, in that position, the antinodes are formed in a vibrating string. Thank you. We will continue this in next video.